This pattern looks complicated, but it's actually one of the easiest fusion workflows you'll ever learn. Let me show you the trick behind it. Let's start with the base sketch. I'll draw a vertical line at 100 millimeters. That sets the total height of the vase. Then I add 2 horizontal lines and fully constrain them just to lock the proportions in place. Now I'll sketch a fit point spline that passes slightly above the top and below the bottom. We're going to come back to why that overshoot matters later, but it gives us a lot more control downstream. I'll adjust the curve using the green spline handlebars until the shape feels right. And finally, I offset that spline by 1 millimeter and close it into its own profile. That might look like an extra step now, but it's a really useful trick. You'll see exactly why when we split bodies later in the tutorial. Now we can turn the sketch into a 3D vase. I'll use the Revolve command and select the main profile defined by the original spline. We'll leave the offset closed spline sketch for later in the workflow. For the axis, I'm revolving around the line that runs through the origin. You can also pick the vertical axis itself. The important part is that we revolve around the origin so the vase stays centered and symmetric. Next, I'm creating 2 offset planes, one above the top of the vase and one below the bottom. I'm offsetting them by about 10 millimeters, but the exact dimension isn't important. It's just handy to keep them close to the body so the workflow stays quick and easy to work with. Now I'm sketching the 2 guidelines that will define the flow of the pattern. On the top offset plane, I'll draw a simple straight line. I'm over-sketching it here. The exact length or position isn't important, as long as it crosses the area where the pattern will run. Then, I'll repeat the process on the bottom offset plane. This time, I'm giving the line an angle. This angled line is what controls the twist of the pattern, and it's one of the most useful parts of this workflow. You can change this angle at any time, and the entire pattern will update with it. We'll come back to this near the end of the tutorial, so you can see how adjusting that line changes the character and movement of the final design. Now it's time to connect those 2 guidelines. I'm using a surface loft between the line on the top plane and the angled line on the bottom plane. This creates a smooth, controlled surface that spans between them. Surface loft works perfectly here because it allows us to loft between open geometry. Now I'll thicken that surface by 1 millimeter, and I'm doing it symmetrically so the shape expands evenly. I'm creating it as a new body. That keeps the workflow clean, and it also makes things much easier later if you want to export 3 MF files for multicolor 3D printing. Now I'll turn the visibility back on for the offset closed spline sketch we created earlier. That sketch is important because it stays linked to the original spline. So if we ever update the main profile, this offset will update with it. With that sketch visible, I'll use Revolve again, but this time set it to Intersect. Intersecting it with the closed offset spline trims away everything we don't need and keeps only the section that falls inside that profile. This gives us a clean curved pattern wrapped around the vase, perfectly matching the shape of the offset spline sketch. Earlier, we created a closed sketch and let the spline extend past the top and bottom of the vase. That gave us a pattern surface long enough to fully cover the vase from end to end. Now we can trim it exactly to the shape we want. I'm using the top and bottom faces of the vase as splitting tools. By splitting the patterned body with those faces, we cut it precisely where the vase ends, with no guessing or manual trimming. Once the splits are done, we can simply hide the extra pieces above and below. That leaves us with a clean, perfectly fitted pattern that matches the vase's exact height. Now I'll shell the vase from the top at 1 mm. If you plan to print it, you might go a little thicker for stability. But keep in mind that layer height matters far more than in fill when it comes to waterproofness. Before we create more bodies, I like to add the appearances now. It keeps the workflow simpler because there are fewer bodies to manage at this stage. I'll start with a glossy appearance, then adjust the colors and duplicate them as needed. Setting this up early makes the later steps much faster and more organized. One thing I really recommend is using custom HTML color codes for your appearances. They give you much more control than the default color wheel, and you can reuse the exact same colors across different bodies, different projects, or even when you export free MF files for multicolor printing. It keeps your designs consistent, and it also makes it easier to build a visual style that feels like your own. You can find great color ideas almost anywhere. Product photos, packaging, nature palettes, or even painted objects in everyday life. There are plenty of free tools online where you can sample any image and grab the exact HTML color code. Once you drop that code into Fusion, you get a perfect match. It's a simple trick, but it really elevates the look of your designs and speeds up your workflow. Now I'll mirror the patterned body, and I'm creating it as a new body. The nice thing about this is that the mirrored body automatically inherits the design of the original one. So if we ever change the first body later in the workflow, the mirrored one updates right along with it. It's a fast way to keep both sides perfectly consistent without any extra work. Before moving on, I'll save this with the short version description. The next steps involve heavier calculations, so it's good to have a clean restore point. Now I'm using a circular pattern to distribute the design around the vase. I'm selecting both patterned bodies and rotating them around the central axis of the model. Using the full pattern distribution gives us an even spread all the way around, so every segment lines up cleanly with the next. This is where the design really starts to take shape, and because everything is parametric, any earlier adjustments will update across the entire pattern instantly. Next, I'm starting a sketch on the top of the vase. I'll use Sketch Project to pull in the edge of the patterned geometry so we have a clean reference to snap to. With that projected edge in place, I can draw a circle that matches the exact outer boundary of the pattern. This gives us a clean, precise ribbon around the top of the vase, and because it's based on projected geometry, it will stay perfectly aligned even if we make changes later in the timeline. If this ends up as a join operation by mistake, just edit the feature in the timeline and switch it to new body. That keeps the original appearance on each part, instead of everything merging together and taking on the black appearance. Now I'll start by sketch projecting the top edge so we have a clean outline to work from. With that curve projected, I'm offsetting it by 3 mm, not to match the wall thickness, but to create a slightly thicker decorative band that gives the top a stronger, cleaner look. Once the offset is in place, I'll use an extrude cut to open up the vase and define the top edge sharply. After the cut, don't forget to apply the appearance to this new surface so it matches the rest of the design. And if you handle this step differently in your own workflow, feel free to leave a comment. I'm always curious how others approach it. Now I'll start a sketch on the bottom of the vase. In the previous step, we used Sketch Project as well, but there we projected more geometry. Here I'm just projecting a single point instead to show that this is another useful option when you only need a simple reference. Projecting that point snaps us to the exact center without any guessing. With that in place, I can draw a circle from the center out to the projected point, giving us a clean and perfectly aligned base shape that will stay accurate even if we make changes later in the timeline. If this base detail accidentally ended up as a join operation again, just edit the feature through the timeline and switch it to new body. Keeping these as separate bodies makes the design easier to manage, and it also keeps the appearances from getting overwritten by the default color of the main vase. Once it's set to new body, I'll add the custom appearance so the base detail matches the style we've used on the rest of the model. Using consistent colors across the different bodies keeps everything clean and readable, and it makes the final design feel more intentional and polished. Before moving on, I'll save this version with a short description. We're about to make parametric edits in the timeline, so it's good to have a clear restore point before we start adjusting the sketches. Now I'll go back and edit the very first sketch we created. As soon as I adjust the spline, the entire pattern updates automatically all the way through the timeline. This is the real strength of a parametric workflow. One small change at the beginning can reshape the whole design instantly. Next, I'll edit the angles of the lofted guidelines we set up earlier. Changing these lines gives the pattern a completely different movement and personality, and it's a quick way to experiment with new looks without rebuilding anything. If you want more vase projects like this, I recommend checking out the 2 tutorials in the suggested videos. They each have hundreds of likes, and hundreds of people subscribe to the channel after watching those.